Alright, so it was under common attacks where we talked about malwares like virus, worms, trojans, ransomwares, and then spywares. Then we're given a reading assignment on social engineering, and yesterday we did had enough talk on phishing. Yeah. So yeah, let's move on to denial of service. Okay, denial of service. So I just want to ask in case. So what in your own words, okay, like your own words, do you think denial of service is? Denial of service. Yeah, so what do we think denial of service is? Why is Kelvin here? Yeah, Mary Kudia. Denial of service. Mary. Denial of service, or it's DOS. What people call it, like DOS. Okay. Alright, so how many of us here remember the CIA triad? CIA, if you remember, just react. Okay, one person, 2, 3, 4, 5. Okay, like six people have reacted. So probably like most of us here remember the CIA triad. Now the A part of the CIA triad, that was availability. Now so denial of service actually focuses on availability, or the availability aspect of the CIA triad. Okay, where attackers are trying to make sure that certain things are not available for certain people. Okay, so if you look at the word denial of service, okay, it's when you are actually denied. I'm just using the same words to explain it. When you actually denied services, okay, legitimate services. A typical example is I think I explained this during the availability class. Okay, so a typical example is let's say you are requesting for something from someone or from somewhere. Okay, and on a normal process or on a normal circumstance, you are supposed to make a request and then get a response, right? But then if someone cuts in and then makes a request and then the person gets a response, makes a request again, gets a response, and then you make your request but you don't get a response, then at that time you are being denied that service, the response. Okay, that is just like an idea to have about denial of service. Okay, so I think I made an explanation about, let me see if I can get this draw.io thing up and running so that maybe I can draw some things here. January. Alright, so I'm just going to get some things here. Let's get this. So let's call this a database server. Okay, or let's just say database, and then let's call this a user. Okay, now so and let's say you want to request information, right? So this is how it goes. So you request for information from the database server, and then you are being given the response. Okay, so Yeah, so request and response goes through in this order. Okay, now that is the flow. You request, you receive, you request, you receive, normal flow. Now availability is there is the resources available for you. Okay, so there's no problem, no wahala here. Okay, now denial of service happens when someone, okay, here, let's call him Kelvin Hacker. Okay, now when this guy decides that since your system is actually weak, he spots a vulnerability, or let's not even call it a vulnerability, but spots your system and decides that, oh okay, I, Kelvin Hacker, right, come on, what is this, I, Kelvin Hacker, I'm going to be sending multiple requests to this one server. Okay, so that is what he decides he's going to do. Okay, so come on, okay, so he decides to send multiple requests to the server. Now let's say Kelvin, right, sends 50,000 requests to the server. Okay, and now let's say your requests are being cascaded, so you have your request actually coming in like using the first come first serve method, where you first sent a request and you got a response. Now 50,000 requests come in. Clear, 50,000 requests come. It's coming at a go. But this Kelvin, he doesn't even need a response for anything. Oh. But you see, the way servers have been designed, they have been designed to always make respond to requests. So the 50,000 requests are going to come. Okay, then your request will come and will be like at something like this, and your request will be here. So now this server would have to respond to 50,000 before it gets to your request. And let's say this database server, right, has a capacity of, let's say, 10,000. Clear. So this server is able to respond to 10,000 requests at a time, but then there is 50,000 and yours is at 50,001. So after 10,000, you are going to overwhelm the server with extra 40,000 requests. If care is not taken, this server is going to crash. Okay, but even before the crashing of the server, now your request now could be 50,001. Into one, you the person that needs the response to actually work, you are not going to get a response because your server is busily replying to 50,000 requests that are not actually needed. Like the request or the response are not needed by the attacker. It's just flooding the server with requests, and you, the legitimate user, you are being denied of your legitimate service. So that is the whole idea behind of denial of service attack. But like I said, if care is not taken, you end up crashing a particular system, and then you interrupt business continuity, which means the company or the system you actually perform their attack on will not be able to continue with their business operations. Yeah. Any question? What is email bomber? I heard about it. Magdalena, what's email bomber?
Yeah, hard. Yeah, email bomber. I learned it from some Russian forum. It's about this. It's like a bot, so you can send you like thousands of email in just a minute. For you
Okay.
to miss the actual email you have to receive.
Okay,
A
so
thousand email, it will be hard for you to know the actual email you have to receive.
yeah, so just listening to the way you explained it makes it different from denial of service. So with the email bomber, like you said, it's not like you are being denied the mail services. You still have everything going, just that you get your inbox flooded with illegitimate mails, and then you end up missing legitimate ones. Okay, but with denial of service, you are being denied a particular service. Let's say the mails don't even come because your mail server is busy attending to other clients. Yeah, so that is the difference between the email bomber and then your denial of service attack. Yeah, so I remember and I made Porsche Siedu. You have been seeing new names every time more. So Porsche is saying that something like that happened when they were checking their WhatsApp results. Yeah. So most of the times it normally happens when we have like mass operations. Okay. So when we are doing things in like let's say huge numbers, that is when it happens because the devices that are actually responsible for rendering those services, might not actually be capable of responding to like that number of requests that is coming in on that day. So for instance, even if you are going to the SHS for admissions and then they are using the online systems, okay, and then like the what's the results checking and then all those things, the first day is something different. Like Charlie, the first day there, like everybody is checking something, everybody is doing something, so it makes the network slow. So you just have to wait for all the ones that want to check theirs first to just check theirs, and then maybe you take your time and also check yours later. Yeah. But like yeah, so denial of service, sometimes that is what happens. Okay, yeah. So the solution was to always make sure that you have devices that can respond to more than the request that is coming, or you have some kind of redundancy in your infrastructure, so that if one server goes down or is actually maybe weak, then the secondary server can kick in and then help with the work. Yeah. Any question? Alright, so if there's no question, we move on to man in the middle attacks. Man in the middle. So I don't know if this thing is still common, but I'm pretty sure people still do it. Man in the middle. Okay. So let's get our draw.io thing here, and then let's see what man in the middle is. Man in the middle. So let's get back our database. And let's get back our hacker. Let's call this Amina. Alright. Okay. So normal transaction or normal procedure. Amina is trying to make a request to let's say the database server. This is like how the request will go through. Okay, then let's get Stone God here. Okay, so Stone God is here. Okay. Nobody talk to me, not to me, no. Yeah, so Stone God is here. So whilst Amina is making requests and then getting response from the database server, Stone God decides to join in and have fun. Okay, so she decides to join the network. Okay, so Stone God decides to join the network. So what happens is she's on the network, and then now the whole process is different. So whatever is moving from here to here, Stone God sees it. I don't know if it's clear. So let's say Amina is sending a request to the database server, right? Whatever request she's sending to the database, since Stone God has joined the network through a man in the middle process, okay, where she's sniffing the network, she will be able to see whatever this person here, okay, what Amina is sending to the database server, and then when the database server is responding, she would be able to see the same thing too again. Okay, so now at some point in time, you would even have attackers being able to modify the request before they reach the server, and then modify the server's response before it's reached to the destination or the source. Okay, yeah, so that is man in the middle attack. But with this form of attack, it mostly used to work on unsecured network, or using when you are communicating over unsecured protocol. But for instance, if you are using an unsecured protocol to communicate over maybe to the database server, then the attacker will be able to see whatever you are sending in plain text. That is when they'll be able to, like, if they are able to modify it, they'll be able to modify it. But if you are communicating over a secure protocol, then it becomes difficult for them to actually understand what is even sent in the first place before they can modify it. But whenever we communicate over secure protocol, most of the times our data is being encrypted before it's sent. Okay, yeah. Any question? Any question? Alright, so now with man in the middle attacks, it's not all the time too that you would have the attacker joining a network. Okay, so sometimes the attacker can cause you to join their network. I don't know if it's clear. So let's say maybe on campus your Wi-Fi name is maybe the name of the school. Maybe why I don't remember the SSID though, but I think it has to be like the name of the school, like it is staff or student. If it's staff, you connect to staff. If it's student, you connect to student here. So if you are on that network and then maybe there's an attacker who's also doing like the same man in the middle procedure or process, they'll be able to sniff whatever is going on the network. Okay, that is what I've just said. Okay, now in some situations the attacker would actually have you join their network. Okay, so where an attacker will create yeah, probably like you wouldn't be able to perform man in the middle attack if the two of you are not on the same network. It's more of like some betweener style B. So if you are not there, you wouldn't be able to do it. Yeah. So I was talking about how attackers will make you join their network. Okay, so attackers can create what we call like rogue access point. Okay, I mean they call it rogue access point. So let's say maybe your Wi-Fi name is something like maybe right, so Akukodo's local, that's maybe like alright. So Porsche is saying that the internet is a network of networks, right? Yeah, what if we are both over the internet? So yeah, the internet is an interconnection of networks, yeah. But if you study networking and then you study routing, you realize that there are certain things that differentiate you from the next person. So we might all be on the internet, but we are on different sites. I don't know if you get what I'm saying. I think maybe at this one, if Gaboni can help us understand, like, oh, Hemfa, is he here? Hey, Roxanne. Oh, yeah. Someone should test Gaboni so that he come and explain this to Portia.
Explain
The internet issue and then the man in the middle. Because, like I was saying, so if we are the whole, let me see. I'm not good with it. Yeah, I'm coming. I'm coming. I'm not good with networking, but I know something small. So let me try and see if I can convince you or either confuse you. But let's try. I'm not going to confuse you, okay? I just hope this thing works. Most of the times it doesn't work when I'm over the internet. So yes, like I said, it doesn't work when I'm over the moment I close it, it will go off. Yeah, it's some wavy. Let me see if there's a way to get it done. I can also get past it. Let me see. Oop. Sign in using the following options, whether you're not Icon Academy or Skills for All account. I don't want to sign in. I just want to use it like normal, okay? But I can't do it when I have the internet connection, okay? But so who is Portia? Portia, can you hear me? Okay, so let's say Portia can hear me, but for some reason she can't talk. Okay, let me just verify if Portia is here. Hey, Portia stuff is not here. Voila. So let me use the draw.io thing to explain if maybe someone else has like another problem with that. Okay, so let's keep this one as maybe I think it wouldn't work that way. Let's have this one as maybe a computer. Okay, that is one computer. another computer. Okay, then we have these ones too here as different computers, right? So then we have a device here, and then we have that same device here, and then we have the cloud here. Okay, so I'm supposed to bring this thing down. Fire. I just hope you all can see what I'm doing. This one, the Gaboni will be the best person to be able to explain it for us. But let me just try. Oba, when it comes, I mean, like, I don't have to do like all the connections, right? Do I have to do them? Some way. I think I could have done just one and then just duplicate it, like, Charlie. No, let me just finish with this one and then duplicate it to the other side so that I don't end up doing a whole lot. Okay, so I'm just going to duplicate the whole thing here. Okay, yay. I just hope the person that asked the question is here. Yeah, so let me check in again. Do we have anything in the chat? Yeah, the packet tracer is not working because my data is still on. Yeah, so no, this is just like a simple network that I've done. Okay, so yeah, like this is a simple network here. So we have network A and then network B. Okay, now this is one part of a network. This is one part of an, and this is what we call the internet. If you are here, you can access here. If you are here, you can access here, but it doesn't mean you are all on the same network. Clear? Oh, who asked the question? Portia, see you do. Portia. So if you are here, right, if you are on this network, you can access this. That is what we call the internet, because there is also a couple of like so many networks there. Okay, there are technologies somewhere here that enable whatever you are doing here to be able to communicate with the other networks. The fact that we are able to communicate with the other networks doesn't mean you are part of those networks. It's just something that is doing something to make sure that your request goes through and then comes through. Okay, so it doesn't necessarily mean that since we are on the internet, we are all on the same network. No, we are just utilizing some technologies, okay, and then those technologies are helping us gain access to the information we want. So if you want to perform a man in the middle attack, you must ensure that you and then the person or the network you are trying to sniff, you are actually part of that network. Or if you can't get if you cannot be part of the network, then what you can do is actually let the people join your network. That's why I say you create a rogue access point, or like maybe attackers will create a rogue access point, and then they'll actually they'll find a ways to make people join. So for instance, if like I said, if your Wi-Fi SSD is akoko.local, which is this SSD here, SSID here, okay, then maybe an attacker also creates the same thing, akoko.local, right, and then put it there. I mean, SSID is not there. Yeah, you are not going to get a message saying that it's already in use. So it's going to register. Now, if you look at the way people connect to Wi-Fi networks, it's just normal. Okay, it's normal with human beings, and we don't really care about what we are connecting. Even if we come and then we scan, and then we see that the SSIDs, one SSID appears like 4 times. We are just connecting. The one that connects. So if the original one is akoko.local, which is the first one here, and then the attacker, a Stone God, also creates akoko.local, that is her network. Now, because her network might be fast, okay, or would actually be stronger than this one, your phone will tend to like try and then pick this one over the legitimate one, or should actually there's not going to be any kind of like security maybe checks on this one, so there's no password the moment our boss are now connected. So in your mind is saying, or to you think, since you've already connected to akoko.local before, that is why the second one is automatically connecting. But it's just because there is no password and it's also strong. So you connect to Stone God's network, and now since you are in on her network, she can now sniff whatever you are doing on the network. Now that is when you are browsing through unsecure protocols. Like I said, if you are using HTTP, FTP, Telnet, and then other things, then yes, yeah, they will be able to find. But I think when you are using secure protocol, it becomes a little bit difficult for attackers to see the exact things that are going on the network, because secure protocols have your data or whatever you are browsing encrypted. Yeah. Any question? Any question? Nah. Alright, so since you don't have question, me, I'll look for question for you, and then we'll see how we'll be able to solve it. Okay, so what would be your suggestion to prevent man in the middle attacks? Let's start with Bedu Prince. Bedu Prince. Okay, El Shaddai, Sandstone. Yeah,
Using
Shaddai.
a trusted using a trusted VPN.
Trusted VPN. Okay, can you help us with why that would help prevent man in the middle attacks?
Because VPNs encrypt your conversations over a network. So when someone intercepts your, even if someone intercepts your network, they can't decipher your message.
Is that so? Okay.
Yeah.
Yeah, we are Bedu Prince.
You see the strong password.
Strong password. We are
Yeah.
not talking about malware, we're talking about man in the middle.
A man in the middle. Yeah. Strong password.
Yeah, how?
Like unique password.
How does it prevent man in the middle attacks?
Like the person will know
The person will know what? Bedu Prince, you said the person will know what? Yeah, Prince, we are listening now. Charlie. I think Prince left. Yeah, so let's hear from Amina Yakubu. After that, we listen to Fatima then.
So you can also check the HTTPS. Yeah. For that one, I think any share sensitive information on the sets with the back padlock. Yeah.
You said the last part, I didn't get it.
I said we can also use checking like the HTTP.
Oh, okay.
And for that one, I take share sensitive information on sets with
Okay.
like something like padlock. Yeah.
Oh, okay. Okay.
Which for that one it can signify an like encrypted connection.
Oh, okay. Okay. Yeah. Fatima. Fatima Ibrahim. Fatima.
Yeah, hello.
Yeah.
Yes. We can also use the IPS.
What's IPS?
Intrusion protection system.
Okay, so what does it mean? What does it mean and how does it help?
The IPS, they protect when they see any suspected suspicious attacker, they make
Mhm.
sure they block the suspicious attacker before he exploit the system.
Oh, okay.
And we have the IDS. So IDS, when they find them, they report to the let's say the IT manager instead of protecting them from the threat. Immediately the IPS finds such things, they take action before they exploit them.
Oh, okay, okay. Yeah, Isaac.
Okay, so I think what I know is avoiding using public Wi-Fi.
Okay.
Avoiding using public Wi-Fi because I think some of the IT personnel they have designed their Wi-Fi that when you on your Wi-Fi you can connect with them. So anything you do, the attacker can connect to you. Then he or she will get your information. So we should prevent or we should avoid connecting to Wi-Fi, connecting to public Wi-Fi.
Okay.
And also I think one more thing is that authentication. The implement multi-factor authentication.
Okay.
Yeah, I think that one too, because when you have that factor authentication, when the connection is coming, it will alert you before it connects. So if it alerts you, you know if that person, if you know that person or you don't know. So that one too can help you to prevent any middle man connecting to your Wi-Fi or connecting or trying to get your information.
Oh, okay, yeah, that's okay. So yeah, you all have said something. Even some of them I've even forgotten there, but I think I remember. Unless I remember the first person I called, the first person I made mention of was I think it was Prince. Yeah, and then El Shaddai talked about VPNs. Okay, so I think I was having problems with understanding how and why VPNs will be able to prevent MITM attacks or man in the middle attacks. So so she said that when you browse over, let's say using a VPN, I don't remember what she said, but I think it has something to do with like making sure that there's like okay, let's just say the concept of VPNs is we create a separate network which you can join that network, and then through that you can connect to maybe a dedicated service or a dedicated system, or you can even use to browse the internet. So your connection goes through a particular channel. So in case maybe there's an attacker on the network, since you are not using alright, I think yeah, so I should be back now. So since you are not using the network itself, since you are not using the network itself, then you would really be able to have your data or your packets channeled through a different route. And the publisher says that the VPNs help minimize the damage by encrypting your traffic. This is not going to prevent MITM, but will serve as an extra step. Yeah. That was why I wanted her to explain how like the VPNs help, because and then she made mention of like using trusted VPNs. Okay, so for me in my mind when she said VPNs, I was like, okay, some of these VPNs are even buggy, like they are even doing these MITM things themselves. Okay, so which one is using VPN? How does it prevent it? Instead like using trusted sources. Okay, so probably if you have your traffic rerouted through a different channel, then you might be on the network but be having your data rerouted through a different place, so the attacker might not get to see the things because he is actually looking on this network A, but maybe your data is moving through network B and then stuff. Okay, and I think Amina Yakubu also made mention of using secure protocol, which also helps, because when you are using secure protocols, like I made mention earlier, you will have your data or whatever you are sending over the network encrypted. So an attacker who is trying to perform anything like man-in-the-middle attack, right, might be able to see your data go through the network, but since it's encrypted, and then if they don't have the encryption key or any way to decrypt it, it might not make sense, and then it wouldn't even be relevant to them as well. Yeah. Then yeah, so that was that one. And I think someone, yeah, so Fatima made mention of IPS and then IDS. So intrusion prevention systems, they work when they detect anomalies. So like intrusion prevention systems will prevent your system from, let's say, something that has been able to detect, like maybe you have, let's say, like a malware coming through the network, or let's say a phishing mail, or anything that is able to detect. Intrusion detection systems will detect them and then raise an alert to the team. Okay, then the team will have to come and check it. Then intrusion prevention system will prevent those things from coming. Now, man-in-the-middle attack is different from the way other attacks work, like maybe sending something to the network. Man-in-the-middle attack is, I am on the network as a legitimate user, I am just sniffing the network. So if you have intrusion prevention systems and then detection systems, it might not be able to I pick out that thing, because the attacker isn't really doing anything harmful on the network. He's only checking the, like, let's say, sniffing the network. And we talk about sniffing, it's just like you are maybe in a friend group, and then you are discussing someone, then someone is eavesdropping. I don't know if that's the right word, like now if there is someone who is like, who knows about maybe, so if there's somebody who knows about maybe, okay, this person is not part of our friends, this person is not part of our friend group, you might be able to identify someone who is not part of a friends group if the person joins the friend group. But here is the situation, you are in a multitude, you don't know who is listening to what, and then who is actually let's say eavesdropping on your conversation. So that one becomes difficult. So IPS, IDS, for me, I think it's going to be a bit difficult for that thing to happen. Yeah. Then I think one person made mention of authentication and then multi-factor authentication to help with man-in-the-middle attacks, which I feel like that one too might not help, because we are not trying to gain, like, certain strong passwords, we are not trying to gain access to an account. Now, if you are communicating over an unsecured protocol and your password is the most secure password in the world, it's going to go in plain text. So even if the attacker is sniffing the network, they would see it. So I think the first one that he said, that was actually one way we can help bring that thing down is avoid joining public networks, okay, or public public networks, because that is how most of the times attackers would use to get you. The moment you join their network, it's theirs. So whatever you are browsing, they are able to see certain things through. Yeah. Okay, so I'm checking any question. If you have any question, ask. I'm checking the link that Portia posted in the group. finding it difficult understanding how this thing works at the man in the middle session, because when I click on man in the middle simulator, let me share my screen so that in case maybe we can't see your screen, he's not sharing his screen, please. So the man in the middle can never happen, attacker not on a network. Yeah, I think yes, we made mention of that. Interception is off by default, so you have to. Okay, so let me share my screen, and then I hope you can see my screen now. Alright, so this is okay. So intercept is on. So it says secure data. I send it. The message is intercepted by the attacker. It gets to this place. I use a regular hash and I just add 0 to it, so I send it. It's intercepted. Okay, so I think I understand what this one is doing. This part is doing it. So when I send, then it actually gets to this side. So
Hello?
if they are, yeah, hello. So with the regular, I don't really understand much about how this thing is working here. Because when you choose regular hash, the data is intercepted, which most systems, when you intercept a request, it will just pause it until we forward it. But when we use the HMAC with a secret key, and then we send the request like this. Okay, so it's paused here, but the first one it didn't pause. Let me just reset it and then send it. Okay, so it pauses here. The attacker gets hold of it, and then the attacker now sends the message. But before that, let me modify it and see. Yeah, okay, sure. I mean, it makes sense. It makes sense. So I'm looking at it from a perspective where this is man in the middle attack, all right, but to actually make sure that we have our stuffs getting there, like the right things getting there, that is why they're actually using some form of hashing. So we send the message plus the hash over the network, so even if the attacker modifies it, they wouldn't be able to, they will be able to identify that, okay, this was happening. But I think another problem with systems too is that if the attacker is able to modify the hash value, then it becomes a problem. Because let's see something. If I send this and then it gets here and then I pause it, right, I don't know what is going to be received here, how it's going, because I'm trying to check something from this side. Send the data gets to attacker sends it, is verified. So when the attacker modifies the data like this, the hash value changes and the attacker sends. So because the two hash values are different, so this is the hash value received from the attacker side, and then they said this is calculated digest. What is this digest for? Before that, let me turn off intercept and then send the data. So we have the same digests. It's calculated from this data, secure data 1, and when I click on intercept and I send, I think this ends in 8586. okay, so this is 8586, and then I modify it to just data and I send it. So how is this thing changing? Let me just come back to the chat. Probably maybe Porsche has some way to, like, I mean, before that, any question before I'm just trying to understand how the tool is working. Any question? Any question? Okay. So I feel like with a regular hash like SHA-256 is what I was looking at it from, because I was thinking if we are sending a message like this, right, and then this message gets to the attacker can modify the message, and then when he gets the hash value, he can send the hash value, and then when you verify and then you regenerate the hash value, it's going to actually match. That is why it says it's verified by compromise. So they are trying to tell us that the regular SHA-256 using hashing and then in this scenario wouldn't work, because an attacker can modify and then resend the hash values. But if you use HMAC, okay, then it becomes different. If you use HMAC, so I think probably I have to look into what HMAC even does, because now I'm not understanding how we are getting different hash values. You see, yeah. So what is it calculating this hash based on? And then this is the receipt. So how is it calculating this hash? Is it that it sees this thing before or what? Anyways, let's okay. So let me check. So with regular hashing, the message plus its hash is sent to the receiver, so that the receiver then hash the received data and compares it. But with HMAC, which using symmetric cryptography, both the sender and then the receiver are sharing a secret key. So even if the so even if the interceptor modifies the message and then hashes it, since he doesn't have the secret key, the receiver is going to know, because only he and the sender have the sure. So HMAC is adding the key to the message before hashing. Yeah, I think now I understand it now. Yeah. So it makes sense now. Alright, so I think it was because of this key thing here. Yeah. Right, now it makes sense. Any question? Any question? And I'm on to the Americano. Any question? Alright, since there's no question, I can pause my recording.